Hello, good morning, dear students. Welcome to Interactive Virtual Class Nagaland once again. So today we will begin with a new chapter. So let us see. Alright. So what do we see here, students? We see here construction is going on. Yes, tall buildings are going on. Now, to build a very tall building, it is very difficult to carry the building materials to the top. Yes. So what do? The construction During the construction, the workers they make use of this crane, okay, to carry up the heavy materials from the ground to the top floor. Okay, so what are these crane made of? Yes, students, we know that these crane are made of metals. Yes, yes, students. So here construction is going on. In construction, we make use of metals. Yes, students, these crane are made up of metals. The next we have another example we have here is we see a car moving along the road. Yes, what are these car made of? These cars are also made of metals and the wire are also made up of metals. Yes, students. And here we see a temple. Yes, students, we see a temple. Here we see a bell, okay, two bells on the temple. What are these bells made up of? Yes, students, these bells are also made up of metals. Another example we see here is a woman is trying to cover the food making use of aluminium foil. Yes, so what is aluminium foil made of? It is made up of aluminium, and aluminium is a metal. So aluminium foil is also made up of metals. Now, let's see here. Here we see a person meditating. Yes, students. So when we meditate, we breathe in oxygen and breathe out carbon dioxide. We are relaxing. Yes. We take a deep breath. Yes, students. So here the person is meditating. So the air that we breathe, okay, is it metals or non-metals? It is non-metals. Okay. Next example we have is a person, okay, a woman is cooking. Yes, students, a woman is cooking. What are these gases made of? Yes, students, these gases are non-metals. Okay, here we see that the handle of the cooking utensils are also made up of plastic or rubber, and these are non-metals. Okay. The next we have here is a boy is drawing making use of pencil. Yes, students. So what are these pencil made of? Yes, students. What are these pencil made of? The pencils are also non-metals, made up of non-metals. Okay. So here. Okay, a person walks into the room and turn on the switch. So what is this switch made of? With what materials? The switch are also made up of non-metals. Okay. So here we see that in our day-to-day lives, we make use of different materials. Yes, students. And these materials are either metals or non-metals. So the materials around us, we can categorize them into metals and non-metals depending on their properties. Okay. So in today's class, we will discuss about metals and non-metals. Okay. So let us see. So here, this is the periodic table. Okay, this is the periodic table of elements. We see three colors. We see yellow, blue, and gray color. Yes, students. So here the gray color represent the metals. Okay, so all the elements under this gray color represents the metals. These are the metals. Okay, and the metals mentioned in the orange color, okay, are the non-metals, and the one in blue color are the metalloids. So let us see. Some examples of metals are iron, aluminium, gold, copper, lithium, nickel, titanium. So those are some examples of metals. some examples of non-metals include phosphorus, oxygen, sulfur, chlorine gas, carbon, iodine, bromine. Okay, so these are some of the examples of non-metals. So here we see that we can categorize the materials into metals and non-metals. So how do we classify them, or how do we categorize them? Okay, we will categorize different materials into metals and non-metals depending on their properties, and these properties of metals and non-metals are also related to the uses of these different materials. Okay, so let us see. So here we see a ball gate, pots, okay, iron nails. Okay, so first we will discuss about the physical properties of metals and non-metals. Okay, the physical properties of metals is different from the physical properties of non-metals. So let us see the physical properties of metals and non-metals. Okay, so here we see some examples of metals. Yes, we see that most of the metals are solids at room temperature. Okay, most of the metals are solid at room temperature. Exception, okay, except there are some exception: mercury, okay, gallium, and cesium. These three are also metals, but they are liquid at room temperature. Okay, mercury is liquid at room temperature, and gallium and cesium has very low temperature. Okay, so these three, except mercury, gallium, and cesium, the other metals are solid at room temperature. What about non-metals? So here we see sulfur is in solid state, bromine is in liquid state, oxygen is in gaseous state. So from here we can say that non-metals occur in solid, liquid, and gaseous state. Okay, non-metals occur in solid, liquid, and gaseous state. So this leads us to the first point. Okay, first physical properties of metals and non-metals. Metals, okay, most of the metals are solid at room temperature except mercury, gallium, and cesium. On the other hand, non-metals occur in solid, liquid, and gaseous state. Now let's see another property. Here we see a person trying to break a iron bar. Okay, now what happens? He hurt his hand instead. Yes, because it is very hard. Now another example here is we see a man burn it first, heat it first to make it into different shape. Yes, so generally metals are hard. Okay, generally metals are hard and they have high density. Okay, exception, there are some exception, except sodium. Okay, sodium is very soft, we can cut with knife, and lithium and potassium. Okay, so most metals are hard and they have very high density, except sodium, lithium, and potassium. These metals are soft metals. Okay, remember this. Okay, sodium, lithium, and potassium are soft metals, and they have low density and low melting point. So let us see for non-metals. We know that the pencil lead is made up of graphite. Yes, so graphite is a non-metal. It breaks easily. Here we have charcoal. Charcoal is made up of carbon. Yes, it's a form of carbon. Now the charcoal also breaks easily. So from here we can say that non-metals are brittle. Yes, we see that the graphite can break easily, the charcoal can also break easily. So non-metals are brittle. Okay, they can break easily, they are not hard. So here we have graphite, diamond, and charcoal. Okay, graphite, here we see that the non-metals, they break easily, so they are brittle. Okay, now we have seen graphite, diamond, and charcoal. These are form of carbon. Okay, graphite, diamond, and charcoal are different form of different forms of carbon. So all these are non-metals, but there is an exception. Okay, there is an exception. We have studied, yes, in our lower class, that diamond is the hardest substance, right? So diamond is the hardest non-metal. So the exception is that non-metals are brittle except diamond, which is hard. Okay, and diamond is the hardest substance. So this leads us to the second physical properties. Okay, generally metals are hard except for sodium, lithium and potassium. They are soft metals. And non-metals are brittle except for diamond, which is the hardest substance. Alright students, this leads us to the first question for today. Please get your rough devices ready. The question is, an element X is soft and can be cut with a knife. The element is very reactive and cannot be kept open in the air. It reacts vigorously with water. Identify the element. So I'm giving you 25 seconds for this question. Students, your time starts now. Yes, students, an element is soft and can be cut with a knife. This element is very reactive and cannot be kept in open air. It reacts vigorously with water. Identify the element. Option A is magnesium, option B is phosphorus, option C is calcium, and option D is sodium. Alright students, your time is up. We have seen that out of this, okay, we see that sodium is a soft element and it can be cut with a knife. So here the correct answer is option D, that is sodium. Okay, very good students. Now let us proceed. Here we see an ice cream man. Okay, the person selling ice cream is ringing the bell. Yes students. So how is that possible? Another example is here a boy riding a bicycle is also ringing the bell. Yes. And here we see a man ringing the bell in the school. Yes. So when you're about to start the class, or when you're about to end the class, or when it is holiday, at the end of the day, the person rings the bell in school. Yes, students. And here another example is a baby playing with a steel spoon and plate. So when you hit, okay, a steel plate with a spoon, it produces a ringing sound. Yes, students. And here a mother is putting on a pile on her daughter. Now when she moves, okay, the pile will make a ringing sound. Yes, students. So the substance that produce a ringing sound when struck are called sonorous. Okay, remember this, students, sonorous. The substance that produce a ringing sound when struck are called sonorous. So you will see that hard metals are sonorous. Okay, the bells are made up of metals. The steel plate are made up of metals. The pile are made up of metals, and these metals, they produce ringing sound. So hard metals are sonorous. Let us see for non-metals. Here we see a boy playing with a ball. Does it produce a ringing sound? No, right? Another example is a tabla. When a person play a tabla, does it produce a ringing sound? No, right? It produces dull sound. Yes, it does not produce ringing sound. So non-metals are non-sonorous. Okay, meaning non-metals, they do not produce ringing sound. So this leads us to the third properties, physical properties of metals and non-metals. Hard metals are sonorous, whereas non-metals are non-sonorous. Now let us see next property. Here we see a woman wearing a jewelry, gold jewelry, right? We see that it is shiny. Yes, students. And here we see a gold belt, which is also shiny. Yes. And here we see a boy. Okay, he took an iron nail and rubbed it on a sandpaper. Okay, we can observe that the iron nail is now shiny. Yes, students. The iron nail is now shiny. So in all these cases, we see that these are all metals. So metals are shiny. Yes, metals in the pure state have a shining surface. So, and this property of shining, okay, this property of shiny property of the metals is known as lustrous. So when we say lustrous, it means shining property. Okay, so metals are shiny. Okay, they have shining surface, so metals are lustrous. Let us take example for non-metals. Take a charcoal, rub it on a sandpaper. We will see that it does not become shiny. Yes, it did not become shiny. So non-metals are non-lustrous or dull. Okay, non-metal does not have shining surface, so they are non-lustrous or dull. Exception, there are exceptions for some non-metals. Graphite and iodine are non-metals which are lustrous. Okay, so these are the only non-metals which have shining surface. So graphite and iodine are exception to non-metals that they are lustrous. So iodine and graphite are shiny, they are lustrous. So activity. Okay, this will be your homework. Rub the surface of the following materials with a sandpaper and make a note of the results. Do they shine? Okay, so rub copper on the sandpaper and observe whether it shines or not. Similarly for aluminum and charcoal. Now you will find out from here which one is a non-metal and which one is a metal. Alright, so this leads us to the fourth physical properties of metals and non-metals. The fourth property is that metals are lustrous, meaning they have shining surface, whereas non-metals are non-lustrous, meaning they do not have shining surface, except for iodine and graphite. Okay. Alright students, we have another question. Please get your rough devices ready. The question is, which property of metals is used for making bells and strings of musical instruments like sitar and violin? Okay, I'm giving you 25 seconds for this question. Your time starts now. Which property of metals is used for making bells and strings of musical instruments like sitar and violin? Option A is ductility, option B is sonority, option C is malleability, and option D is conductivity. Yes, students. So which property of metals is used for making bells and strings of musical instruments? Alright, students, your time is up. Now, we have seen that there is a property of metals, okay, which produce a ringing sound. And this property, because of this property, they are used for making bells and strings of musical instruments. Yes, and we have seen that property is known as sonority. So here the correct answer is option B, that is sonority. Okay, good students. Now let us take another example here. See the next property. We have seen this earlier. Yes, a woman is covering the food that she has prepared with an aluminium foil. So here his son is asking, Mom, what are you using to bake the rotis? Okay, then the mother replied, it is aluminium foil. Now here the boy is wondering, how can the aluminium be used to make a thick container and a thin foil? Okay, we have seen that these utensils are also made up of aluminium. Yes, it is very thick, whereas this aluminium foil is also made up of aluminium. So how is this possible? The boy is wondering. Okay, so let us see here. Another example we have here is tin bottle cap. Okay, when you hammer tin bottle cap, you will see that it is beaten into thin sheets. Yes, it is beaten into thin sheets. Then take aluminium wire and hammer it. Okay, you will see that it is again beaten into thin sheets. Yes, students. Again here we have fruits. We see that there is a shiny particles on the surface of these sweets, right? So these are silver foil. Okay, so silver foil is used to decorate sweets. And here we see a temple. At the entrance of the temple, you will observe that there are thin layer of gold to make the entrance look more attractive. Yes, students. So here the girl, when she visits the temple, she is impressed with the beautiful entrance. Yes. So in all these examples, we see that the metals are beaten into thin sheets. Aluminium foil is made into thin sheets. Aluminium wire is made into thin sheets, right? So some metals are malleable. Okay, malleable. or malleability. Okay, is the property of metals with the property of metals, okay, through which it can be beaten into thin sheets is called malleability. Okay, so if metals can be beaten into thin sheets, we will say that they are malleable. So some metals are malleable. Okay, examples of malleable metals are aluminum foil, it can be beaten into thin sheets, chromium sheets, copper sheet, silver sheet, gold sheet, zinc sheet, and iron sheet. So these are some of the examples of malleable metals. From here we can see that it can be beaten into thin sheets. Yes, nowadays, okay, gold and silver are the most malleable metals, meaning they can be beaten into thin sheets. Okay, gold can be beaten without any specific difficulty to a thickness of 0.1 micron. Okay, so gold can be beaten into a very thin sheet without any specific difficulty. Now let us see for non-metals. Charcoal is an example of non-metals. Now what happens when we hammer charcoal? It breaks, right? It breaks into small pieces. We cannot make it into thin sheets. Yes, students. So from here we can see that non-metals cannot be beaten into thin sheets. So they are non-malleable. Okay, non-metals are non-malleable. So another activity for you students, use a hammer and beat the following substance hard and find out what happens. So this will be your homework. Okay, copper wire, hit the copper wire, iron washer, graphite. Okay, hammer them and see what happens. And from their property you will be identify whether which of the following is a metal or which of the following is non-metal. So precaution, take care that you don't hurt yourself while carrying out this activity. So this leads us to the fifth property of metals and non-metals. Some metals are malleable. Okay, they can be beaten into thin sheets, whereas non-metals are non-malleable, meaning they cannot be beaten into thin sheets. Here we see a father and a son walking by the road. Then the boy asks to his father that what are the wires made of? Okay. Then the father replied, they are made of copper. Now again the boy is wondering. Okay. Copper ball is also made of copper. How can this thick copper be converted into this wire? Okay. So the boy is wondering. So let us see. Okay. So some metals are ductile. Okay. So what is ductile? The property of metals which can be made into thin wires, okay, are known as ductile, okay, or ductility. So some examples of ductile metals, let us see. Here the boy is visiting the shop and he is asking for electric wire. Okay, can you give me electric wire? Then the shopkeeper offered him copper wire, then aluminum wire, then chromium wire, silver wire, zinc wire, and tin wire. Okay, so these are some of the examples of ductile metals. It can be made into wires, into a thin wires. Okay, so that property of metals which can be made into thin wires is known as ductility. Know this, students. Here we see gold necklace, right? So it is also made in the form of wire. So gold is the most ductile metal. A wire of about 2 kilometers can be drawn from 1 gram of gold. Okay, so from 1 gram of gold, just imagine 1 gram of gold. Okay, it can be drawn into a wire of about 2 kilometers. Okay. Now let us see for non-metals. Take a charcoal again, beat it and see if we can make into a thin wire. It breaks, we cannot make it into thin wire. Yes, students, so non-metals are non-ductile. Okay, so this leads us to the 6 physical properties of metals and non-metals. Some metals are ductile, meaning they can be drawn into thin sheets, thin wires, and non-metals are non-ductile, meaning they cannot be drawn into thin wire. Okay, don't get confused with malleable and ductile. Malleable is beaten into thin sheets, whereas ductile means drawn into thin wires. Okay. Alright students, we have another question. Please get your rough devices ready. The question is, the property by which metals can be beaten into thin sheets is called. I'm giving you 25 seconds for this question. Your time starts now. The property by which metals can be beaten into thin sheets is called. Option A is ductility, option B is sonority, option C is malleability, and option D is conductivity. So which of the following is the property by which metals can be beaten into thin sheets? Yes, students? Alright, students, your time is up. And yes, very good. The correct answer is malleability. The property by which metals can be beaten into thin sheets is called malleability. And the property by which metals can be drawn into thin wires is called ductility. So here the correct answer is option C, that is malleability. Very good, students. Now let us see here. Here we see a woman cooking. Okay. Now he's making use of a cloth to lift up the cooking utensil from the stove. Yes, students. Why is it so? Why is she using the cloth? It's because the pot is hot, right? Now let us perform an experiment to see. So take a stand like this. Okay. Take a stand. This is the copper wire. Okay. This is the copper wire and this is the burner. Now put some wax. Okay. Put some wax on this copper wire. Okay. Now take a burner and heat at the tip of the copper wire. Let us observe what happens to the wax. Okay. So when we heat the copper wire, you will see that after some time the wax begins to melt. Yes, students, you are heating the copper wire here, but the wax are melting here. Why is that so? It is because the copper wire has heated up. It has heated up, it became warm, it became hot, and so the wax melted away. So metals are good conductors of heat. Okay, when you heat metals, they heat up, they become hot. So metals are good conductors of heat and they have high melting point. Metals should be heated to a very high temperature in order to melt them. So even when we cook, okay, even when we cook using utensils in a fire, it does not melt. Yes, we are able to cook our food using aluminum utensils because it does not melt easily, but it is a good conductor of heat, so it helps us, or it helps the food to get cooked. Yes, so metals are good conductors of heat and they have high melting point. Know this. Copper, silver. Okay, the best conductors of heat are silver and copper. Remember this, students. Silver and coppers are the best conductors of heat, whereas lead and mercury are poor conductors of heat. Okay, lead and mercury are also metals. Silver and copper are also metals, but silver and copper are best conductors of heat, whereas lead and mercury are comparatively poor conductors of heat. They conduct heat, but they are comparatively poor conductors of heat. Now here we see that in a utensil we make use of rubber or plastic to make the handle. Yes, students, because this pot is made up of metals. It is a good conductors of heat. It heats up. So when we touch the pot, we burn our hands. But when we make the handle with plastic or rubber, okay, we prevent ourselves from getting burned. Yes, students. So let us take another example here. Take and perform an activity. So take the same stand. Replace the copper wire with wooden stick and put some wax on it. Now see, okay, what happens when you hit the tip of the wooden stick? So when you hit the tip of the wooden stick, you will see that this portion of the wood will get burned, but the wax does not melt. Yes, students, the wax does not melt. It is because even though this part is getting burned, the heat is not transferred to this side. So from here we can say that non-metals are bad conductors of heat. Okay, exception is that diamond and graphite. Okay, diamond and graphite are good conductors of heat. Diamond and graphite, they conduct heat. So repeat the experiment with aluminum rod and iron rod and record the observation. So instead of taking copper wire and wooden stick, take aluminum rod, put some wax on it, heat the tip of aluminum rod. Similarly for iron rod, and record your observation. You will find out whether aluminum rod and iron rod are good conductors of heat or poor conductors of heat. So this leads us to the 7 physical properties of metals and non-metals. Metals are good conductors of heat, whereas non-metals are bad conductors of heat, except for diamond and graphite, which are good conductors of heat. Now here we see another property. Let us see another property. Here a man is trying to fix a bulb into the socket, but he could not reach it. So he asks his son to get him a stool. Okay, get me a stool, I can't reach the socket, says the father. So the boy went to fetch a stool. Now he brought a stool made up of metals. Now what happens? Let us see what happens. Now when he stood on the metal stool and tried to fix the bulb into the socket, we see that the man is getting electric shock. Yes. So here, this is the circuit, setup, battery, bulb, copper wire. Okay. Now what happens when we connect these two wires with metals? Let us see. Okay, so when we connect these two metals with copper wire, okay, the bulb glows, meaning copper wire is a good conductor of electricity. So metals are good conductors of electricity. Okay. Now let us see for non-metals. Do non-metals conduct electricity? The father asked the child to get him a wooden or a plastic stool. Okay. So the boy went to bring a wooden or plastic stool. He brought back a wooden stool. Now when the man stood on this wooden stool to fix the bulb into the socket, we see that he did not get electric shock. Yes, it is because the wooden stool does not conduct electricity. Taking another example, the same setup, connect these two wires with, when we connect these two wires with copper wire, we see that the light bulb glows. It is because it is a good conductor of electricity. But when we connect these two wires using a charcoal, the bulb does not glow. It means that the charcoal does not conduct electricity. So bulb does not glow. So from here we can say that charcoal is a bad conductor of electricity. So non-metals are bad conductors of electricity. There is an exception to this. Graphite is a non-metal which conducts electricity. So think over. Okay, think over. Copper wire. You will see that these are the wire. Yes, but the wires are always covered with plastics or rubber. Yes, why is this so? Why plastic coating is used around electrical wires? It is because these wires are good conductor of electricity. So when we come in direct contact with these wires, we will get electric shock. However, the plastics are poor conductors of electricity. So when we cover the wires with this plastic, even when we come in contact with it, we will not get electric shock. Okay, that is why plastic coating is used around electrical wires. Activity: repeat the experiment with the following materials and record your observation. Okay, so make the same setup of the circuit, then connect two wires using aluminum nail and check whether the bulb glows or not. Similarly, take wood plastic scale and you will see which of the following substance is a good conductor of electricity and which of the following substance is a poor conductor of electricity. Okay, so this leads us to the 8 physical properties of metals and non-metals. Metals are good conductors of electricity, whereas non-metals are bad conductors of electricity, except for graphite, which is a non-metal which conducts electricity. So far in today's class, we have discussed about the 8 physical properties of metals and non-metals. Alright students, we have another question. Please get your rough devices ready. The question is, aluminium is used for making cooking utensils. Which of the following property of aluminium is responsible for the same? So I'm giving you 25 seconds for this question. Your time starts now. Aluminium is used for making cooking utensils. Which of the following property of aluminium is responsible for the same? Option A is thermal conductivity, option B is high melting point, option C is ductility, and option D is both A and B. Alright students, your time is up, and yes, very good. The correct answer is option D, that is both A and B. We use aluminium for making cooking utensils because it is a good conductor of heat and it has high melting point. If it has low melting point, the aluminum utensils will melt away. We will not be able to cook food. If it is a poor conductor of heat, then our food will not get heat up, so it will not get cooked. Yes, so the properties responsible for making cooking utensils with aluminum is because of its thermal conductivity and high melting point. Very good students. Now recall, okay, recall property, the different property of metals. So we see that the property of metals includes thermal conductivity, which means it is a good conductor of heat. Then we have electrical conductivity, meaning metals are good conductor of electricity. Ductility, the property of metals by which it can be drawn into thin wires, is known as ductility. And here we see a metals drawn or beaten into a thin sheet, is known as malleability. And the next we have is the property, okay, lustrous, meaning it has the shining surface. Sonorous means the property of metals by which it produces ringing sound. And the last we have is strength. Metals are very hard, yes, and they have very high melting point and have high density. So these are the property that we have discussed today. Okay. Now more to know. Okay. Here we see a person meditating, we see animals, we see plants, right? So oxygen is a non-metal which is essential to maintain life of all living beings. Fuels. Non-metals like carbon and hydrogen are major constituents of fuel burning in homes, factories, and vehicles for support. So these are some of the uses of non-metals. Okay, know this. Here we see that we have discussed about metals which are in gray color. We have also discussed about the non-metals which are in yellow color. What about the one in the blue? Okay, the metalloids. What are metalloids? Yes, students. So metalloids are those, okay, elements that exhibit some properties of metals and some properties of non-metals. Okay, so elements that exhibit some properties of metals and some properties of non-metals are called as metalloids. Some example of non-metalloids include boron. Okay, it include boron, silicon, etc. Whereas non-metals occur in solid, liquid, and gaseous state. Metals are generally hard, whereas non-metals are brittle. Hard metals are sonorous, whereas non-metals are non-sonorous. Metals are lustrous, whereas non-metals are non-lustrous. Some metals are malleable, whereas non-metals are non-malleable. Some metals are ductile, whereas non-metals are non-ductile. Metals are good conductors of heat, whereas non-metals are bad conductors of heat. Metals are good conductors of electricity, whereas non-metals are bad conductors of electricity. These are the physical properties of metals and non-metals. There are some exceptions to some of the physical properties. Students, you try to remember the names of the element in the exceptions. Okay. Alright students, so this leads us to another question. Please get your rough devices ready. The question is, generally non-metals are lustrous. Which of the following which of the given non-metals is lustrous? Okay, I'm giving you 25 seconds for this question. Your time starts now. Generally, non-metals are lustrous. Which of the given non-metals is lustrous? Alright students, your time is up, and yes, very good. The correct answer is option B, that is iodine. Alright students, so this leads us to the last question for today. Please get your rough devices ready and respond to this question. I'm giving you 10 seconds to respond to this question. Your time starts now. How do you feel about today's class? Yes students, kindly give your feedback about today's class. Happy, quite good, satisfactory, confused. Alright students, your time is up. Thank you so much for your response and thank you for joining today's class. I will see you again in our next class. Till then, take care everyone and have a nice day.